We're back and better than ever. We're in 11.2 where we're going to show you how to classify reactions. We're actually entitled Types of Chemical Reactions. And the first reaction that we want to look at is what's called a combination or a synthesis reaction. And all you're doing with a combination or synthesis reaction is taking two or more reactants and forming only one product. All right. A good example of that is simply taking, you can take nitrogen gas and hydrogen gas and forming ammonia gas. I'm not going to balance these right now. We'll leave them as skeleton reactions or skeleton equations. But the idea of just making one product, that's the idea of a combination reaction. Now on the opposite side of that is what are called decomposition reactions. That's taking your one substance and then breaking it back down into two or more components. For example, you could take calcium carbonate, CaCO3, solid, and if you heat this thing up, so I'm going to put a triangle over the top of the arrow. If you heat that up, you're going to produce calcium oxide and carbon dioxide gas. So that would be considered a decomposition reaction, taking one substance and breaking it down into individual parts. You also have what are called single replacement reactions. Okay? A single replacement reaction is simply taking an element and swapping it out with another element that's already in a compound. So if we have A plus B bonded to C, what's going to happen is this compound, or this element, is going to swap out with that one. That's just going to go off on its own. So you're going to be left with AC plus B. A great example of this is taking aluminum. You can take aluminum foil and put that in a solution of copper 2 chloride. Excuse me. When you do that, the aluminum is going to replace the copper, so you're going to be left with AlCl3 due to the charge on the aluminum, and then the copper is going to go off on its own. It's going to look like that. That's Cu, solid. You actually saw that reaction in the metals, nonmetals, and metalloid lab, where you put the aluminum foil, or you actually put the copper 2 chloride over the top of the aluminum foil in one of the test tubes. A lot of people thought that the aluminum was rusting. In fact, no, it wasn't rust. It was copper metal coming out of solution. The next type of reaction is what's called a double replacement. A double replacement reaction has two items swapping one another. So if we have A, B reacting with C, D, what happens is one ion swaps out with the other one, and then that will also replace that particular element. So you're going to produce AD plus CB. Alright, so it's a double swap going on. A great example of this one, I love this reaction, is taking lead nitrate in solution, that's AQ, plus, say, potassium iodide, that would also be in solution, AQ, and that's going to produce a wonderful yellow lead 2 iodide, solid, plus potassium nitrate, still in solution, AQ. Alright, so again, notice that the lead swapped out with the potassium, and the potassium swapped out with the lead. Alright, so there's your double replacement. Next, we have what are called combustion reactions. A combustion reaction is going to take something, I'm just going to say X, and you're going to react that with oxygen, and it's going to produce some products plus energy. So we could take anything. I'm just going to use, we'll go with propane, C3H8, reacting with oxygen. That's going to produce carbon dioxide and water. Alright, so there you go. That's a combustion reaction, and it's going to be releasing energy as well. So those are the first 5 reactions that we want you to be familiar with. Combination, decomposition, single and double replacement, and combustion reactions. Alright, now if I scroll down, there's another set of reactions that you should be aware of. The first one is what we would consider acid-base. Acid-base, the key here is that you form water from an acid. Now, not all reactions that involve acids are acid-base, but if it forms water from the acid, it is. Common example would be simply taking HCl plus sodium hydroxide, and that would produce water and sodium chloride. So here's your water formed, and it's coming from an acid, so that would definitely qualify as an acid-base reaction. Alright, next we have what's called a precipitation reaction. A precipitation reaction forms a solid from 2 or more solutions. We've actually seen one of these already in a previous example. If you take your lead nitrate and you react that with potassium iodide solutions, notice they're both AQ. AQ, AQ. That's going to form lead 2 iodide solid plus potassium nitrate, which is also AQ. The key here is you're forming a solid from 2 solutions. This solid is called your precipitate. And that's why it's called the precipitation reaction. Okay, moving on, redox reactions. Redox reactions involve electron transfers. They can be somewhat difficult to, well, I want to say they're difficult to spot. Actually, the ones that we're going to be giving you are very easy to spot. All you really need to look for is a pure element on either side of the equation. If you see a pure element on either side of the equation, it's going to have to undergo some type of redox reaction. All combustion reactions will be redox reaction because they involve elemental oxygen. So if I take methane plus oxygen, boom, as soon as you see a pure element, oxygen, you know this is going to be redox. It forms carbon dioxide and water. Another redox reaction that we've already shown you is taking ammonia and hydrogen to form, nitrogen and hydrogen to form ammonia. That would also have to be a redox reaction because you're seeing an element, a pure element, on one side of the equation or another. Alright, so that's a redox reaction. Okay, we're starting to run a little bit low on time here, so we'll wrap up types of reactions, and then also we're going to show you how to predict whether or not a single replacement reaction is going to occur. We'll do that next time.